To yet another video, and this video is the part of GM elementary course for beginners. And today we are going to talk about the rate of change of various kinematic variables. Of course, one of them, and first and foremost, is the displacement. तो हम लोग डिस्प्लेसमेंट के रेट ऑफ चेंज के बारे में भी बात करेंगे. बट you know, the displacement itself is the change in position. So getting the rate of change of displacement is straightforward. You simply need to divide the displacement by the time interval in which it takes place. मान लो कि पार्टिकल एक्स एक्सिस के लॉन्ग मूव कर रहा है, देन द एक्स कोऑर्डिनेट ऑफ द पार्टिकल आर डिजिग्नेटेड एज इट्स पोजीशन. सिंपली द एक्स कोऑर्डिनेट. अगर ऑब्जेक्ट एक्स एक्सिस के लॉन्ग मूव कर रहा है तो वो ऑब्जेक्ट किसी भी पॉइंट पर होगा, उसका कुछ एक्स कोऑर्डिनेट होगा, एंड दोज एक्स कोऑर्डिनेट्स आर बेसिकली डिजिग्नेटेड एज इट्स पोजीशन. सो चेंज इन पोजीशन मीन्स चेंज इन एक्स कोऑर्डिनेट. सिंपली इट इज रिटन एज डेल्टा एक्स. And if delta x is the displacement in a finite time interval, say delta t, मतलब ये delta x का जो भी displacement है, ये अगर delta t time interval में हो रहा है, तो you can define simply its rate of change as delta x upon delta t. और ये जो डेल्टा एक्स बाई डेल्टा टी नाम का फिजिकल क्वांटिटी जो हमने डिफाइन किया है, इट इज़ नेम्ड एज द एवरेज वेलोसिटी और द मीन वेलोसिटी. एवरेज इसलिए कि बिकॉज इट हैज़ बीन डिटरमाइंड इन ए फाइनाइट टाइम इंटरवल. अगर इस फाइनाइट टाइम इंटरवल को हम काफ़ी स्मॉल कर दें, इफ़ वी टेक द लिमिट्स एज डेल्टा टी टेंड्स टू जीरो, delta t tends to 0, that is time interval is made so small that it can be referred as an instant, then you should write the things like limit delta t tends to 0 delta x by delta t. This is a new thing, new term, and this is not the average velocity. Once when delta t tends to 0, this thing is called dx by dt. You know from calculus, and this thing is simply referred as instantaneous velocity or simply velocity. You can write it dx by dt, this thing. That means this thing is dx minus x naught by dt, x naught being the initial position and x is the position of the object at any arbitrary time t, and x minus x naught, where x naught will be a constant. So if you differentiate the things x minus x naught with respect to time and x naught being constant, you will simply get dx by dt, and that is in any case you can say the rate of change of position or rate of change of displacement. These are the same things. If you like to write x minus x naught, the displacement, simply as s, then you can write it as ds by dt as well. So the rates of change of a kinematic quantity is basically divided into two parts. एक पार्ट को हम एवरेज बोलते हैं जब टाइम इंटरवल को फाइनाइट लेते हैं, जब उसी टाइम इंटरवल को काफ़ी स्मॉल कर देते हैं, then we call it simply velocity or instantaneous velocity. That means the rate of change of displacement is simply called velocity. If the time interval is finite, then it will be called the average velocity. If it made as delta t tends to 0, then we will call it the velocity. तो ये पहली चीज़ तो हो गई. सेकेंड थिंग जो है, नेक्स्ट थिंग, इसमें डिस्टेंस ट्रेवल्ड या पाथ लेंथ का भी रेट ऑफ चेंज वी कैन कैलकुलेट. यू कैन कॉल इट डिस्टेंस ट्रेवल्ड इन standard terminology of physics, or you can call it path length, because it is the length of the path for a given displacement. So, and the rate of change of displacement, rate of change of the distance traveled is defined as the average speed. And you know how to get the instantaneous value from the average one, that if you make the time interval very close to zero, then you will get your instantaneous speed, and you are free to call it the speed. And if path length or distance traveled is defined by L, you can write it as L upon delta t, or this will be our average speed, or you can write it as dl upon dt. That will be the instantaneous speed or the speed. Since the speed and velocity may have different values for the same journey in same time interval, I am referring. Same journey means same time interval. तो स्पीड और वेलोसिटी के वैल्यूज डिफरेंट हो सकते हैं, बट इफ दे आर सेम इन ए पर्टिकुलर केस, का ऐसे भी केसेस मिलेंगे, डिफरेंट तो हो सकते हैं इन जनरल, बट ऐसे भी केसेस मिल सकते हैं जिसमें कि डिस्टेंस ट्रैवल डिस्प्लेसमेंट सेम हो, सो स्पीड और वेलोसिटी दोनों के वैल्यू सेम होंगे. इन केस हम लोग इसके लिए भी, तब उस केस में हम लोग इसको भी सिंबल दे सकते हैं वेलोसिटी के लिहाज से, और इसको भी बोल सकते हैं. द वेलोसिटी v इज द स्पीड v, बट इट विल बी अ पर्टिकुलर केस. इन जनरल दोनों के वैल्यूज डिफरेंट होंगे, तो यूज डिफरेंट नोटेशंस फॉर देम. एंड नेक्स्ट थिंग आई वुड लाइक टू डिस्कस हियर कि द रेट्स ऑफ चेंजेस में बी ए कांस्टेंट और वेरिएबल. ये जो रेट ऑफ चेंज हमने कैलकुलेट किया है, इट में बी ए कांस्टेंट और वेरिएबल डिपेंडिंग ऑन द कोर्स ऑफ मोशन ऑफ कोर्स. एंड वी विल फोकस फर्स्ट ऑन द कांस्टेंट वेलोसिटी एंड स्पीड. मतलब हम लोग उस किस्म के मोशन डिस्क्राइब करेंगे जिसमें वेलोसिटी या स्पीड कांस्टेंट होगी, जिसके लिए हम लोग इक्वेशंस इस तरीके से लिख पाएंगे. अगर एक्स एक्सिस के लॉन्ग मोशन हो रहा है तो वी कैन राइट डी एक्स बाई डी टी इक्वल्स भी, एंड भी बीइंग अ कांस्टेंट. और इस केस में हमें जो सॉल्यूशन मिलेगा इस इक्वेशन का, अगर वेलोसिटी कांस्टेंट होगी तो ये जो इक्वेशन है हमारा, इसको डिफरेंशियल इक्वेशन बोलते हैं. और इस डिफरेंशियल इक्वेशन को जो सॉल्यूशन मिलेगा वो इंटीग्रेट करके मिलता है. यू कैन राइट इट एज डी एक्स इक्वल्स बी डी टी. सिंस बी इज ए कांस्टेंट, इट कैन बी टेकन आउट ऑफ द इंटीग्रेशन साइन. एंड इफ वी आर मेकिंग indefinite integration, you can write x equals vt plus a constant. I would like to write it x naught in this case. So you will have the solution of this equation in form of this. हाँ, आप इसको इस तरीके से भी लिख सकते हैं. एक्स नॉट को इधर ले आओ आप, तो इसको आप लिख सकते हो एक्स माइनस एक्स नॉट इक्वल्स वी टी इक्वल्स वी टी. एंड एक्स माइनस एक्स नॉट को आप डिस्प्लेसमेंट या डिस्टेंस ट्रेवल्ड अगर आपके सेम हैं, दोनों के वैल्यूज सेम हैं, तो यू कैन राइट इट लाइक डिस्प्लेसमेंट इक्वल्स वी टी. और इफ़ द डिस्टेंस ट्रेवल्ड इज सेम एज द डिस्प्लेसमेंट, यू कैन राइट इट एट डिस्टेंस ट्रेवल्ड इक्वल्स स्पीड इनटू टाइम. सो ये सब तो चीज़ें हैं. अगर कांस्टेंट है, इस मोशन को यूनिफॉर्म मोशन भी बोलते हैं. हालांकि यूनिफॉर्म मोशन का मतलब कांस्टेंट वेलोसिटी नहीं होती है. यूनिफॉर्म मोशन का मतलब कांस्टेंट स्पीड होता है. द यूनिफॉर्म मोशन इज व्हेन द स्पीड इज कांस्टेंट, बट if the motion is along a straight line and its speed is constant, then its velocity may be also constant. Velocity will be also constant. And then if you think, you can, since it fits under the criteria of uniform motion, you can tell it a uniform motion, no problem about. But uniform motion, the term uniform motion is referred to, is related to the constant speed, not the velocity. So keep this thing in mind. But I would like to talk about something else also here. Because we sometimes need to treat displacements and velocities as vectors, not as mere numbers. And in such cases, their handling requires a bit cautious approach. वेक्टर्स होने का जो मतलब होता है, ये पता नहीं आपको पता है या नहीं है, या जितनी मेरी जानकारी है उतनी ही आपकी भी होगी शायद. मुझे भी ज़्यादा मालूम नहीं है वेक्टर्स के बारे में, सिवाय इसके कि इट इज़ ए डायरेक्टेड लाइन सेगमेंट. दैट मीन्स इट मे हैव ए डायरेक्शन along with the magnitude. सो लेंथ तो हमें हर हालत में मिलने वाली है, लेकिन इसका एक डेफिनेट डायरेक्शन है. दैट मीन्स डिस्प्लेसमेंट्स एंड वेलोसिटीज कैन बी रिगार्डेड एज वेक्टर्स. डिस्टेंस ट्रेवल्ड एंड स्पीड कैन नॉट बी रिगार्डेड एज वेक्टर्स. सो sometimes you need to treat the displacements and velocities as vectors. For example, मान लो कि वी हैव एन ऑब्जेक्ट ए. सिंपली ऑब्जेक्ट का नाम मैंने रखा है ए. एंड यू ऑब्जर्व्ड दैट इट हैज़ ए वेलोसिटी वी ए. से इट्स वेलोसिटी ऑफ ऑब्जेक्ट ए, यू कैन राइट इट एज वी ए. सो सिंस वी आर यूजिंग वेक्टर एज अप्रोच, you should write with a different notation. You should place an arrow over the term VA. Then everybody will recognize that you are treating the given physical quantity as vectors. It's simply a notation, nothing else. And next thing you can do, that you can write something like an identity that VA will be equal to VA, and if you subtract something like VB from him, B is another object, VB is the velocity of another object B, then VA equals VA minus VB is not correct thing to write here, but you should write it like this, that VA equals VA can be also written as VA velocity of A equals velocity of A minus velocity of B plus velocity of B. And here VA minus VB is called the velocity of A as observed by B. VA minus VB, it is called Galilean transformation basically, and this term VA minus VB together is called the velocity of A as observed by B, or you can call it the relative velocity of A with respect to B. That means B is the observer and A is the object, and B is also observing the velocity of B. This simply says that if you are observing the velocity of an object A and you don't have the first hand information of velocity of A, you cannot see A, but you have to observe the velocity of A. So vision wise, you might not have the first hand information about velocity of A. Rather, some other observer is providing you this info about the velocity of A. A के बारे में आपको कोई दूसरा आदमी बता रहा है कि A की वेलोसिटी इतनी है. तो in such case you cannot register the velocity of A simply by VA, because you are the observer and you don't have any information about velocity of A. The information came from other source, that somebody B is telling you the velocity of A, and you just got the information VA minus VB, VA vector minus VB. Then VA in such case, velocity of A in such case can be simply written as VA minus VB plus VB. Mathematically, you can see that. So, in a nutshell, if you are observing the velocity of an object A and you don't have the first hand information of velocity of A, rather some other observer is providing you this info about the velocity of A, and in that case The information provided by B about A cannot be simply rewritten as VA vector. What you will register should be written like this: vector VA, vector VB minus, vector VA minus BB, sorry, vector VA minus BB. And then to find VA, you need to add this thing, BB alone, BB again with this information, and then you will get the VA. This is quite simple, mathematical, and direct mathematical relation confirms your observation. And you can do not only with the displacement alone, you can do this with the displacement and acceleration vectors as well. And this thing is called the Galilean transformation in physics. इसी को गैलीलियन ट्रांसफॉर्मेशन कहा जाता है फिजिक्स में. हालांकि this is not the only transformation in physics. There are some other transformation like this. When you deal with an observer moving at higher speed, such as the speed comparable to the speed of light in vacuum, then this is called the Lorentz transformation in the name of H.A. Lorentz. And I hope you will be in touch with the concept itself when studying about the relativistic mechanics, either here or in college. And then you need something else too. You need to learn about the vector drawings of the statement, this statement, and this statement. Simply because they provide a comfortable working environment when dealing with vectors. And how can you do this? So VA minus BB can be drawn by in different ways, right? VA minus BB can be drawn in this manner: VA plus minus BB. And then if you have the velocity of, if you have an arrow known as vectors for velocity of A like this, and you have a different arrow for velocity of B like this, then you need to draw minus BB that will be exactly of the same length of the BB but in a direction opposite, exactly opposite to BB. So this is my minus BB. And then you need to do one thing. You need to draw another arrow from the tail of VA and to head of minus BB. And this thing you will get will be VA minus BB. Of course, you need a formal training about vectors, but this I think is the formal training for vectors. Though if you want a separate lecture for vectors, I can do this, but I usually do in this manner. Or you can do in another manner. Since two vectors are added like this, if there is a vector A and there is another vector B, then just we need to find the sum of vectors A and B. We simply need to join the tail of vector A to the head of vector B, and this is our vector A plus B. This is usually called the head-tail method, and you will be much familiar pretty soon. But you can do this directly, then like VA minus VB, you can draw something like that. You can draw your VA, draw your VB, tail to tail, and then you simply join the heads of these two vectors. And since you are looking for VA minus VB, let's call it a vector C. We don't know. VA minus BB equals vector C. And then you can see from here, from a little bit mathematics, nothing else, that VA will be equal to vector C plus vector BB. So you need to add vector C with vector B. And where is your vector C? How can you find, if you put an arrow like this for vector C, then you know here vector B, at the head of vector B, there is a tail of vector C, and these two are getting added to vector A, vector BA, like this. So if you want to know simply the difference of two vectors, that is VA minus BB, you can apply this approach too. You can simply write VA, simply represent the arrows of, simply draw the arrows of vector VA and vector BB, and then join their heads. And if it is VA minus BB, then you can put an arrow towards VA, towards the arrow of VA, and you will get your VA minus BB. और इसका उल्टा करें अगर, तो that will be BB minus BA. And you need to practice this thing. A vector is a displacement, and displacements are added like this. What are the rules of adding vectors? We don't worry. You don't worry, because this is adding two vectors or subtracting two vectors is some kind of geometry of triangles. So we don't need any ordinary algebraic method to add the vectors. We will do some geometry always, and we will find the values, the magnitudes, always. We don't need any extra information about vectors, though I don't need. But in case you need them, I will show you at the right place. And definitely I will show you some examples of handling with vectors as well in a different language. For now, you need to watch this video more than one times, so you can be familiar with those things. These are theoretical things, and I have to keep this video short, but you can see the proof of that relative velocity constant, that Galilean transformation, that BB plus BA minus BB is BA here. And you need a bit geometric approach, a bit of geometry, not much. And you don't need a separate lecture on vectors, because in my life I have seen people getting confused more when they got a lecture on vectors, and not talking in terms of displacement and velocity. If they simply study vectors, they get more confused. So I decided to utilize vectors in kinematics with kinematical reference. But if you need one, you can tell me, and I will give it to you. So just think about those things, nothing else. I have to say nothing else at this moment. And thank you very much for watching. You can say that your lectures are very small. It will get bigger in time, right? These are smaller because I wanted to deliver small lectures at the beginning, and they will get bigger. इसका अगला वीडियो इससे बड़ा होगा डेफिनेटली. थैंक यू वेरी मच अगेन.